Hi, and welcome to this demo of our Microsoft Fabric powered anomaly detection solution designed specifically for financial institutions. Financial fraud is a growing threat in Kenya, with institutions losing millions annually due to weak and outdated fraud detection systems. CBK's 2023 fraud report highlighted a 21.3% surge in fraud related losses. Financial institutions, which serve more than 20 million Kenyans, are especially at risk. Studies show that 68% of fraud cases are detected too late, with the recovery rates below 15%. A good case is Equity Bank's 1.5 billion insider fraud with just 47 transactions. Thus, the urgent need for intelligent real-time transaction monitoring. This solution is built with one goal in mind: real-time anomaly detection and alerting. With no predictions here, we are focusing on precision flagging of suspicious transaction patterns as they occur, helping institutions act before the damage is done. So let me take you through our solution mind map. So we ingest data through a data pipeline to Microsoft Fabric's Lakehouse, and then after ingesting, we prepare the data. All these processes involve data preparation to ensure that we have the right features for detection. After getting the features, we select them um, and normalize and prepare them to so that we can select the correct features for the model. In our case, we are going to use isolation forest algorithm. We using the selected features, we train and test the data. After the training, we analyze the results using GPT-4 Mini and classify them in order to make it easy to work on the urgent cases. After analyzing those results, we use that feedback to visualize the results where one can get clear details on the anomalies. After getting the clear details, now that's where Power Automate triggers the alert, which can be sent through an email or even a Teams message for prompt action. Let me take you through our work. So, our solution is developed in three steps. One, train the model, test the data for anomalies. Two, use OpenAI GPT-4 Mini to analyze the anomaly level, that is, classify them into low, medium, or high, along with the explanation to the deductions and the message that will be sent to the risk analyst. Step three is connect to Azure Blob Storage, upload a TXT file. The text in here is the alert message content with crucial information for the anomalies found. After the last step, Power Automate takes over from here. We've set up a trigger to listen to addition or modification of files in the blob storage and the steps to send the emails of the alert message. So the step one involves training and testing the data for anomalies. So we select the features we selected here include account numbers, transaction posting date, transaction time, transaction amount, rolling average, which is the mean of the total amount transacted by each account, the previous transaction time, that is the last time a certain user transacted, if the transaction is a first, and then the time since last transaction, that is the time difference between the last and second last transaction for each account. So we read the data and then select the features as I highlighted earlier. And then after having the features ready, we now develop our model. So in this case, we split the data for training and evaluation. So in our case, we used isolation forest machine learning model, which is ideal for financial data due to its effectiveness in identifying outliers in high dimensional skewed datasets, especially where anomalies are rare and subtle. So we go ahead to train the isolation forest model. We predict the anomalies on the scaled data, convert the predictions now to anomaly and normal, and then go ahead to have a new column now called status, where we have the categorizations, that is the anomaly transaction or is it a normal transaction. From there, we go ahead to now have the data and the new column added. So as we can see here, we have now the categorizations are done. You can see we have normal, and since it's only showing top 20 rows, we only have normal here, but the data includes even anomalies. So after that, we continue to fine tuning our table, and then uh, uh, on this step, we select the anomaly results only. So this is what we are going to feed to OpenAI GPT-4 Mini. So step two, we use OpenAI GPT-4 Mini to analyze the anomaly level, that is, and then categorize them just as I highlighted earlier. So this comes along with explanations to the detections and the message that will be sent to the risk analyst. So we go ahead to develop the functions, and then right here we call the function. After calling the function, we save the results back to the lakehouse, but in a new table. So this new table is now what we have as anomaly risk summary. So after that, we connect to Azure Blob Storage with the TXT file. At this point, a storage account is already created on Azure along with the blob container that we will use to store the uploaded files. The final cell in this section will log a message to show if the connecting blob container is successful, if uploading the anomaly files is successful, and lastly, a verification to show how many items are currently in the blob container. So once we have our blob updated, um, we go ahead now to trigger the we to trigger our alert. So the blob is added. We have a list of variables here to determine what alert will be sent, and then later on we send an email, and this can be seen right here with the succeeded logs that we have, and then an example of an email that was sent as anomaly now to a potential risk analyst is that a transaction of 30,000 shillings from account number this has been flagged for review due to detected anomalies. Please investigate for potential fraudulent activity. So this is not just all. This is not just all. So there's an option for setting up event streams. So this will allow real-time data ingestion and live alerting. However, due to limited access to a live transactional database during development, we couldn't implement it fully. So this was just a few minutes overview, but everything, code, documentation, and deployment steps is available on GitHub. We hope this solution inspires confidence in how modern data platforms and AI can be used to protect financial institutions in a real time. Thanks for watching, and feel free to reach out if you'd like to collaborate. Thank you.